Page 92. Puzzle. Tamarind seeds. Sunita took some tamarind, that is, imli seeds. She made groups of 5 with them. And found that 1 seed was left over. She tried making groups of 6 and groups of 4. Each time 1 seed was left over. What is the smallest number of seeds that Sunita had? On the right side of the page, we see a picture of Sunita with her tamarind or imli seeds trying to create groups of 5, 6 and 4, one after the other. For the teacher. Encourage children to try out themselves such activities using seeds, pebbles, etc. Page 93. More tamarind seeds. A Minnie is arranging 12 tamarind seeds in the form of different rectangles. Try to make more rectangles like this using 12 tamarind seeds. How many different rectangles can you make? If there are 15 tamarind seeds, how many rectangles can you make? On the top right corner of the page, we see a picture of a Minnie trying to arrange 12 tamarind seeds in the form of different rectangles. Coloring the grid. Below this we see a huge grid space and lots of colors all around it. In the grid here, a rectangle made of 20 boxes is drawn. The width of this rectangle is 2 boxes. What is its length? Color a rectangle made of 20 boxes in some other way. Page 94. What is the length and width of the rectangle you colored? In how many ways can you color a rectangle of 20 boxes? Color them all in the grid. And write the length and width of each rectangle you have colored. Bangles. There are 18 bangles on the rod. Meena is trying to group them. She can put them in groups of 2, 3, 6, 9, and 18. Without any bangle being left. On the right side of the page, we see the picture of Meena along with a boy arranging the bangles in different groups. How many groups will she have if she makes groups of one bangle each? Dash. Now complete the table for different numbers of bangles. For each number, see what different groups can be made. Column 1 is for number of bangles. Column 2 tells us the different groups we can make. For example, 18 can be put in different groups of 1, 2, 3, 6, 9, 18. The second number 24 and the different groups we can make: 1, 2, dash. Rest of the column 2 is empty for your answers. 5, 9, 7, page 95. Fill the chart. Complete the multiplication chart given here. The chart comprises of sequence of numbers from 1 to 12 going from left to right horizontally and top to bottom vertically. The first cell of this table or chart is a cross. Some numbers are mentioned on the grid spaces like 12, 20, 21, 40, 72, 66. Observe the green boxes in the chart. These show how we can get 12 by multiplying different numbers. 12 is equal to 4 multiplied by 3. So 12 is a multiple of both 4 and 3. Twelve is also a multiple of 6 and 2, as well as 12 and 1. We say 1, 2, 3, 4, 6, 12 are factors of 12. Page 96. What are the factors of 10? Dash. Can you do this from the chart? On the right side, we have a small table with 10 written at the top and the first factors written down below it, like 5 multiplied by 2. Then there is a blank space for your answer. What are the factors of 36? Dash. Find out all the factors of 36 from the multiplication chart. What is the biggest number for which you can find the factors from this chart? What can you do for numbers bigger than that? Common factors. Write the factors of 25 in the red circle and the factors of 35 in the blue circle. There are two circles overlapping each other slightly in the middle. Which are the factors you have written in the common part, that is, purple, of both circles? These are common factors of 25 and 35. On the bottom left corner of the page, we have a picture of a woman asking, what are the factors written in the common, that is, purple part of the circle? Which is the biggest common factor of 40 and 60? Page 97. Factor-2. Look at the factor tree. Now, can you make another tree like this? We see a factor tree below this with numbers 3, 9, 2, 18. Shown as different balls connected by lines with each other. There is another factor tree drawn to the right side of it with all white balls and blank except the bottom one with the number 18 written in it. In how many ways can you draw a factor tree for 24? Draw 3 of them below. There are 3 white rectangle spaces given below with 24 written at the bottom in a ball and the connecting lines drawn for you to continue. Try drawing the factor tree using other numbers also. Tiling problems. 1. There is a garden in Anu's house. In the middle of the garden there is a path. They decided to tile the path using tiles of length 2 feet, 3 feet, and 5 feet. The mason tiled the first row with 2 feet tiles. The second row with 3 feet tiles, and the third row with 5 feet tiles. The mason has not cut any of the tiles. Then what is the shortest length of the path? Page 98. 2. Manoj has made a new house. He wants to lay tiles on the floor. The size of the room is 9 feet by 12 feet. In the market, there are 3 kinds of square tiles. One foot by 1 foot, 2 feet by 2 feet, and 3 feet by 3 feet. Which size of tile should he buy for his room? So that he can lay it without cutting. Three. We have a picture in which we see 3 different houses marked as Rani's house, Geetha's house, and Nasima's house. Three girls are standing outside the houses at a distance, talking to each other. There is a road a little far off from the houses, and all the houses are at 90 feet distance from the road, shown by 3 different lines. Rani, Geetha, and Nasima live near each other. The distance from their houses to the road is 90 feet. They decided to tile the path to the road. They all bought tiles of different designs and length. Rani bought the shortest tile. Geetha bought the middle-sized one, and Nasima bought the longest one. If they could tile the path without cutting any of the tiles, what is the size of the tiles each has bought? Suggest 3 different solutions. Explain how you get this answer. For the teacher, it will be useful to have a discussion about a foot and how we use it often to talk about our own heights. Children can use their centimeters scale to get an idea about how long a foot is.